David Smith here with another Flip Classroom math video. A few tips before we get started. First, remember that you can slow down or speed up the playback if that helps you follow along. You can also pause the video at any point to perfect your notes, or if you want to try the problems before I explain them. Lastly, remember that you could turn on the captions and read my words going along the bottom of your screen. Okay, this is the first lesson of a new chapter. We're covering quadratic equations. So a little bit of basics before we start solving some of these. The general form for the equations in this lesson are x squared equals k. And the x squared, particularly because it's got a squared on it, is what we call the quadratic term. So a quadratic equation is any equation that has an x squared on it. In this case, these are the most simple quadratic equations. It's just x squared equals k, which is some constant. Could be 68, could be 100, could be some kind of a number. So this is the basic form of those equations. Now we're going to complexify that a little bit as we go. Another thing to talk about. In our last chapter, we did factoring, and we factored expressions. So there wasn't an equal sign involved. We just took an expression and we factored it. In this case, now we're dealing with equations. So if you remember from the beginning of our year together, we talked about the difference between expressions and equations. So expressions are things that we can simplify, or we can factor, or we can expand. Equations are things that we can actually solve. And what that means is, what is x, really? Not just leaving it alone in the expression, but let's get a number for that. Let's find out what x can be. Okay? So let's take a look at how that works. Solve for x. Here's a real basic quadratic equation. X squared equals 4. So before I start, it's assumed prior knowledge that you do know how to solve equations. So if you're rough on that technique, like dividing both sides by the same number, multiplying both sides by the same number, adding or subtracting the same number from both sides, if you're rough on that, you'll want to review. Okay, so x squared equals 4. I need to get x alone. That's what solving an equation is all about. So if I want to get rid of the x squared, I can just do this. The square root of x squared equals x. So what that means I'm going to do is I'm going to take the square root of both sides of this equation. That's going to give me x on one side, and this is going to be the square root of 4. Now if you know your square roots, which you should because we did a chapter on radicals, what's the square root of 4? That's just 2, right? So this ends up being x equals 2. Now I want you to think real hard. Are we done? If you came up with no, you're right. Now think about why there might be another answer to x squared equals 4. Okay, if you realized that negative 2 times negative 2 also equals positive 4, you were right. So this equation has two answers. And so what we really do, I'll just start it over here, is we go x squared equals plus or minus the square root of 4. And this little plus minus tells us that we have two solutions. We have a positive one and a negative one. So this would be plus or minus 2. So that's our solution, plus or minus 2. We can also write it like this. That's set notation, and it's showing our two solutions in a set. So we have positive 2 and negative 2. Okay? All right, so I want you to pause the video and try that one. Okay, let's see how you did. I'm going to do this in a real step-by-step way. X squared equals plus minus, don't forget that, root 144. So then x equals plus minus 12. Okay? So don't forget your plus minus. You won't get full points on a test or a quiz if you don't remember that there's two answers. So to review, every time you take a square root, you end up with a plus minus somewhere in your equation. These ones are pretty straightforward. It's going to get a little more complicated as we go. Try that one. This is a little different. Notice how I don't have x squared alone. I've got a 2 out there. Pause the video, see if you can do that. Okay, so what I can do here is I can divide both sides of the equation by 2. I'm going to write that out here. Divide by 2. Sometimes I'll put that notation out there. I know students will do this as well, just to show us what we're doing. So dividing each side of this equation by 2, I'm just going to write it all out. That means the 2's cancel, and I have x squared here, and 72 divided by 2 is our friend 36, which is a nice perfect square. So that's going to give us x equals plus or minus 6. Okay? Okay, here's 3 problems that we're going to take a look at. X squared equals 29. Let's do our stuff. Take the square root of both sides. So x equals plus minus square root of 29. Now, 29 is prime. There's nothing else we can do with this. We are done. Don't get out your calculator and find out what the decimal is for root 29. Just leave it as root 29. Let's do one more like this one. X squared equals 20. Now this one's going to work out a little differently. Let's do it. Take the square root of both sides. Get rid of the squared. This is root 20. Now, 20 is not prime. And in fact, 20 has some perfect square factors. So we need to finish simplifying. Root 20 is the same as root of 4 times 5. The 4 comes out, and we get 2 root 5. So you have to simplify your radicals. Now, I missed something in there. See if you can catch it. I forgot my plus minus. Plus minus, plus minus, plus minus. Now, I'm glad I did that because I want to see if you can catch that. I guarantee you, when you work the homework, you're going to make that mistake from time to time. Just make sure that when it comes time to take a quiz or a test, that you don't make that mistake. Okay, so try that one. It's kind of different. X squared equals 0. Okay, let's take the square root of both sides. So that gives me x equals the square root of 0. Now, what's the square root of 0? Oh, my plus minus. What's the square root of 0? It's just 0. 0 times 0 is 0, so the square root of 0 is also 0. Now we don't need to say plus minus because 0 isn't positive or negative, it's just 0. It doesn't matter whether you add or subtract it, it's just 0. So we got x equals 0. Okay? Notice how we don't have 2 solutions, we just have 1. Okay? Try that one. Okay, let's see how you did. Take the square root of both sides. X equals the square root of negative 64. Now, last step, right? What do you think about that? 2 things should bother you. 1, I forgot the plus minus, so that's the first one. But now, the second one is more fundamental. What's the square root of negative 64? I wrote negative 8 to see if you would catch that. The way to check is, if I square this, I should wind up back at the negative 64. But negative 8 times negative 8 is positive 64. So if you recall from the radicals chapter, as soon as we have a negative under the root sign, we don't have a solution. We can't take negative square roots. So at this point, that's not a thing. And this tells us that there's no solution. Okay? So when you work these problems, as soon as you find something negative under the root sign, you're done. You can stop and you can say no solution. Now some people like to write NRS for no real solution, and it's true that we have other types of numbers that we can use to solve a negative square root. They're called imaginary numbers, which is why we say no real solution. We need imaginary to solve that. And you'll get that later in your mathematics career, but right now we're just going to say no solution when you have a negative under the root. Okay, we're going to do a bunch of examples. The best way to get comfortable solving these equations is just do a lot. So I got 5 here. Feel free to pause the video at any point and try on your own. Here's a basic one. X squared plus 3 equals 6. So solving equations, I want to get x alone. My first step is to subtract 3 from both sides. I get x squared equals 3. So x is going to equal plus or minus the square root of 3. Now there's nothing else I can do. 3 is prime. Don't put it in your calculator and show me a decimal. Just leave it as plus or minus root 3. Okay, let's try that one. X, I'm going to subtract or add 2 to each side. So I'm going to get, hang on, let's make some more room. Add 2, x squared equals 18. X equals plus minus square root of 18. Now, 18 has a perfect square factor in there, because we can now say plus minus root of 2 times 9, and 9 is a perfect square, so it comes out as its square root, so we have plus minus 3 root 2. So that's our answer. So if you remember from our radicals chapter, we had answers that I was starting to call ugly answers. They've got a lot going on. They've got roots and things outside the roots. And now we have plus minuses. So get used to that. That comes with the territory in these types of problems. Okay, let's try this one. Subtract 11 from each side. X squared equals 81. This is a nice one. 81 is a perfect square. So take the square root of both sides. I'm going to get plus minus 9. So the square root of 81 is 9, but I have to remember my plus minus. So 2 solutions. This one's a little bit more tricky. I'm going to give us some room. I'm going to erase this answer from that problem. Let's do it this way. I want to isolate x. So I'm going to subtract 3 from both sides. And I'm going to get minus 2x squared equals 7. 3 from 7 gives me 4. Now I need x alone, and I also want it positive. So I'm going to divide through by negative 2 on both sides and get x squared equals negative 2. Take the square root of both sides. X equals plus minus square root of negative 2. Where are we at? No solution. That's a negative number under the root sign, so I'm going to write NRS for no real solution. Okay? Give that one a try. It's a little bit more complicated, but not too bad. I'm going to subtract 5. So I get 6x squared equals 150. I subtracted 5 from both sides. Now I want to divide through by 6. X squared equals, now what's 150 times 6? 25. Take the square root. X equals plus minus root 25, which is plus minus 5. Okay, 3 problems that are in a more complicated form. Same process, but just more picky algebra to keep track of. Okay, so first one. I have x minus 2 squared equals 25. So instead of just an x term, I have a binomial squared. But if you remember the technique we used last time, we just do the same thing. So to get the squared off this term, we're going to take the square root of both sides. So that's just going to turn this into x minus 2. Now I have equals the square root of 25, plus minus, which is going to be plus minus 5. Okay? So I have x minus 2 equals plus or minus 5. Now this is where it gets a little complicated. I have 2 equations to solve now. I have x minus 2 equals positive 5 and x minus 2 equals negative 5. So I'm going to do a branch. X minus 2 equals 5 and x minus 2 equals negative 5. And this is going to give me my 2 solutions. This one, I'm going to add 2 to both sides and get x equals 7. And here I'm going to add 2 to both sides as well and get x equals negative 3. Those are my 2 answers. If you stop there, that's fine. If you like set notation, you can do it like this. Okay? So to review, this one, because I have a term over here that I didn't take the square root of, I end up with a branch. 2 ways to go. I have to solve this equation for positive and solve it for negative 5. Okay? Now if you feel ready, try that one. Really similar. Okay, let's see how you did. Square root of both sides. X minus 3 equals, so what's the square root of 64? It's 8, but we're plus minus, so it's plus minus 8. Now I have my branch. One of them is x minus 3 equals 8. and the other one is x minus 3 equals negative 8. So two equations to solve. Add 3 to both sides, x equals 13. Add 3 to both sides, x equals 5. So two solutions, 13 and 5. Now I see already I made a boo-boo. See if you can catch it. What did I do wrong? Adding 3 to negative 8 leaves me with negative 5. So that's a negative there. Okay, try that one. See how you do. Okay, let's do that. Square root of both sides. X plus 1 equals plus minus root 7. So far, so good. Now I have two equations again. I have x plus 1 equals root 7, and I have x plus 1 equals the negative of root 7. Now this is going to start to give us a little bit of what I call ugly answers. Subtract 1 from both sides. I get x equals negative 1 plus root 7. I'm not going to combine these. I'm just going to leave the root 7 alone by itself. So I subtracted 1, got negative 1 plus root 7. This side I'm going to do the same thing, subtract 1, and I get negative 1 minus root 7. So two answers here. And I can write it in this interesting way, negative 1 plus minus root 7. That's fine. You can do it that way if you like, because really that's what I've got, negative 1 plus and negative 1 minus. So we can do a little shorthand there if we like. Now that you've finished the video, take a moment to jot down any questions that you have so you can bring them to our next class and get some help. You could also watch the video again to perfect your understanding. If you enjoyed the video, please click the like button down below, and if you'd like to help me grow my YouTube channel, please click subscribe.